Additionally, the James Webb Space Telescope, JWST, is a scientific research tool that has discovered amazing facts about stars, galaxies, planets, and other cosmic phenomena. Similar to how the World Wide Web was created, it sets the standards for scientific research, praised as the renowned Hubble Space Telescope. People from all over the world have accessed the telescope, sharing photos or utilizing raw data to produce new insights. It has been a year since the formidable James Webb Space Telescope revealed its first-ever image of the universe, surprising astronomers around the world with its staggering amount of detail. Regardless of how current its discoveries are, it is a stunning illustration of the universe that has never existed before, compared to what has been discovered thus far. The images that the James Webb Space Telescope provides raise more questions than they answer, and scientists continue to investigate how the most astonishing photographs ever captured by the telescope challenge our comprehension of space. The Hubble telescope's new data, revealed by the telescope's successor, has provided insights into star formation, galaxy mergers, and the beginning of the cosmos. A month before the first images were made public, they were breathtaking, showing the entire universe in stunning detail. Since then, the number of discoveries has skyrocketed, providing scientists with an irreplaceable treasure trove of information from the James Webb Space Telescope's archive. The cosmos has been observed by the telescope, including space phenomena that broke records, such as the Tarantula Nebula, stars on the verge of exploding, and other exceptional celestial objects. This satellite, with the cutting-edge technology of the observatory, allows us to see deeper into space than ever before, revealing something previously unknown and providing details about a new era in the universe. Astronomy has entered a new era, thanks to the precise and detailed images from the telescope. To commemorate the first year of the James Webb Space Telescope's operation, NASA released an image showing a tiny region within the Rose Structure Oumuamua Cloud Complex. The picture shows new cosmic dust bursting into jets from stars, clouds of diverse colors colliding. Purple is made of molecular hydrogen dust, and the presence of a circumstellar disk casts a shadow on a few stars, pointing to the possibility of planet formation. While this image might depict cosmic mayhem, NASA claims this stellar nursery is quite small and peaceful compared to others. Numerous local rising stars are about the same size as our Sun or even smaller, making it the closest star-forming region to Earth. This close-up, captured by the observatory's main infrared camera, is a stunning picture. The telescope's capacity to observe in the infrared light spectrum has significantly improved our understanding of exoplanets, worlds orbiting stars other than our Sun. The James Webb Space Telescope is particularly adept at observing massive, distant galaxies. The first exoplanet, LHS 475b, was detected at the beginning of 2023. The planet is 41 light-years away and has a diameter comparable to Earth's. NASA claims that the James Webb Space Telescope is the only operational telescope capable of categorizing the atmospheres of Earth-sized exoplanets. The results demonstrated how accurate the telescope's exoplanet observations are, opening a brand new horizon for astronomers to investigate. Following this, the telescope found evidence of long-known galaxies that, theoretically speaking, should not exist. A team led by Swinburne's Evolutionary Lab for Astronomy, along with an international group of researchers, discovered 6 universe-spanning galaxies from the early universe. These massive galaxies, which may have formed between 500 and 700 million years after the Big Bang, could completely alter our perception of space. With the advanced tools of the Webb telescope, scientists can glimpse back in time approximately 13.5 billion years, showing the stars and galaxies that formed much earlier than expected. This discovery has puzzled scientists, as the early universe's galaxies were thought to be 10 to 100 times smaller than these. According to calculations, these 6 objects may be billions of times heavier than the sum of all the stars in the galaxy that makes up our solar system, likely 100 billion times heavier than the sheer magnitude of these findings. These results challenge existing theories. The majority of galaxies formed from this era are thought to be small and only gradually increasing in size. However, some monstrous galaxies appear to have grown at an accelerated rate. It remains unclear what sparked this rapid expansion or how it functioned. Penn State University assistant professor and co-author Leah Joel expressed surprise at the discovery of a new class of massive galaxies forming in the beginning of the universe. This discovery challenges numerous previous notions of cosmic evolution and is truly remarkable. It has forced the scientific community to reconsider fundamental ideas about the formation of galaxies. Galaxies from the early universe are considered infants because they are still developing their structure. However, some galaxies in the early cosmos appear as old as our own, contradicting previous assumptions. Spectroscopy, which breaks down light into distinct wavelengths, permits precise distance measurements necessary to confirm these findings. Researchers are currently attempting to confirm the accuracy of the data, as only a few of these recently discovered objects have undergone extensive mass and distance testing. If these discoveries are correct, galaxy formation would need to have occurred significantly faster and more effectively than previously thought. Spectroscopic analysis has provided promising results that support the images captured by the Webb telescope. For decades, scientists have tried to decode the history of the universe, and the Webb telescope may hold the key to answering some of the biggest questions in cosmology. However, conflicting data from telescopes sometimes leads to gaps in understanding. Dr. Katie Mack, a cosmologist, has offered insights into the situation, explaining how JWST discoveries could challenge long-held theories. The Webb telescope has provided evidence of galaxies forming much earlier than expected, but as Mack noted, astronomers shouldn't worry about their models just yet. The telescope is obtaining images of galaxies larger than 13 billion light-years away, meaning they appear hazy and far away. There may not have been enough time since the Big Bang for such enormous galaxies to have formed according to current cosmological timelines. Some scientists worry that these findings could challenge theories about dark matter and the Big Bang itself. However, further investigation is required before drawing conclusions. As the James Webb Space Telescope continues to explore the far reaches of space, its discoveries are reshaping our understanding of the cosmos in profound ways. The telescope's ability to peer into the depths of the universe has provided insights into areas that were once beyond our imagination, revealing previously hidden phenomena, such as the formation of galaxies and stars, the birth and death of celestial objects, and the intricate processes that govern the universe's evolution. Scientists are now investigating more than just distant galaxies. The Webb telescope's infrared capabilities allow researchers to study some of the most ancient and elusive objects in the universe. The first stars, which formed over 13 billion years ago, are being observed in unprecedented detail, helping astronomers refine models of how the universe began and evolved. The telescope's findings suggest that star formation may have started much earlier than previously thought, potentially altering our understanding of the timeline of cosmic evolution. Moreover, the telescope has also provided valuable information about exoplanets in the habitable zones of distant star systems. Its ability to analyze the atmospheres of these planets, detecting potential signs of habitability, such as the presence of water or organic molecules, is bringing scientists closer to answering one of humanity's most profound questions: are we alone in the universe? The Webb telescope's groundbreaking work is not limited to cosmic phenomena. It is also having a significant impact on the study of our own solar system. The telescope has captured stunning images of planets, moons, and comets, providing new insights into their atmospheres, geology, and potential for life. For example, its observations of Jupiter's moon Europa have sparked renewed interest in the possibility of subsurface oceans, where microbial life could exist. Similarly, its study of Saturn's moon Enceladus has revealed complex geologic features, indicating the presence of active hydrothermal activity beneath its icy surface. As the mission continues, the Webb telescope will likely provide even more revolutionary discoveries that challenge our understanding of physics, cosmology, and the nature of the universe itself. With its advanced technology, scientists are already planning future missions that will build upon the Webb's legacy, pushing the boundaries of space exploration even further. In addition to its scientific breakthroughs, the James Webb Space Telescope is also serving as a symbol of human ingenuity and collaboration. Developed by NASA, in collaboration with the European Space Agency, ESA, and the Canadian Space Agency, CSA, the telescope represents a remarkable achievement in international cooperation. Its success demonstrates what can be accomplished when countries come together to push the boundaries of scientific discovery. As we look to the future, the James Webb Space Telescope will continue to serve as a beacon for astronomers, guiding the way toward new frontiers of knowledge. With each new image, each new discovery, it invites us to dream of a future where the mysteries of the universe are no longer distant puzzles, but tangible questions that we can answer, one star, one galaxy, one exoplanet at a time. Questions demonstrating that the pursuit of knowledge is far from over. The discoveries made by this groundbreaking observatory will undoubtedly shape the future of physics, astronomy, and our comprehension of the universe for future generations. Data containing predicted spectra for galaxies with characteristics similar to this redshift tells us the exact point in the universe's history as seen by us. Many galaxies appear to have an excess of stars that were too young or stars when they would have lived. According to there are a number of model spectrum comparisons. There are a number of possible reasons this could be the case. It's possible that photometric readings were off because of problems with the telescope's calibration, or they might have been found in a group of galaxies that is not typical of the norm or very small regions of the sky. Another possibility is that the models of the galaxy spectrum that are designed for closer galaxies do not work well with galaxies farther away. On the other hand, cosmologists might need to deal with the exciting possibility of being required to rethink cosmic evolution if those galaxies are indeed extremely large and earlier estimations were wrong. Then, we need to reevaluate our understanding. However, this is hardly the only place where scientists have fallen short. Despite advancements in technology, planets that are simply too extensive have astonished experts, none more so than the discovery of a planet that is believed to be too big for its star, resulting in a re-evaluation of our collective understanding of planet creation and solar system architecture. Additionally, the models that astronomers created in the period following the discovery of a planet 13 times as large as Earth in a system of planets centered on the ultra-cool dwarf star LHS 3154 have changed our perspective. A 9 times larger star, smaller in size than our Sun, according to a news statement, has a mass-to-weight ratio 100 times higher than Earth's ratio to the Sun. Prior to the most recent findings, scientists didn't think such a scenario was possible, but brand new evidence indicates that the largest planet in our solar system is indeed orbiting one of the smallest and coolest things in the universe, an extremely cool dwarf star. We still know very little about the cosmos, and this discovery proves it even more. A planet of this mass orbiting a star with such low mass shatters our expectations. Stars may have originated in large gas and dust clouds, and planets may have arisen from the gas and dust that remained in the disk of material surrounding the newborn star. However, it was not anticipated that the change would occur. The planet around the low-mass star LHS 3154 would include sufficient solid mass to produce this planet, but since it exists, we must now re-evaluate our theories concerning stellar and planetary formation. A good example would be to contrast the star to a campfire. In order to maintain your body temperature, you must move closer to the fire because its temperature goes down with distance. Planets are no different. Planets are pushed around by gravitational forces in the same way we would feel warmth from a fire. The Earth, for example, needs to be much closer to its star in order to improve enough force to keep its orbit intact because a star with low mass cools much faster than a star of greater mass. Our understanding of planetary formation and evolution may need to be revised in light of this discovery. This massive planet, found orbiting a low-mass star previously thought incapable of hosting such a planet, challenges existing theories. Although researchers have discovered planets with diameters up to 12 times greater than Jupiter's, the more we learn about space, the more pressure we face to re-evaluate our previous assumptions. Astronomers have always aimed to comprehend how everything works in the universe. The James Webb Space Telescope, JWST, may eventually provide the missing components. Right now, the JWST is observing Jupiter's moon Europa for signs of life in our solar system. The second Galilean satellite has long been considered one of the most likely places to host life beyond Earth. Although it is icy, scientists believe there is a large subterranean ocean beneath it. The ice shell of Europa is even more intriguing, featuring shattered surfaces, fractures, and an environment akin to the Arctic. Additionally, massive plumes of water vapor emerge from the ice shell. Scientists believe the ocean beneath is the source of these plumes. Using the infrared capabilities of the JWST, scientists will analyze the surface properties and chemical makeup of Europa in detail, given the opportunity to look for life's chemical signatures. The JWST may be able to detect plumes erupting as a result of the surface's activity. As astronomers continue to explore Europa's fascinating chemistry, the JWST is expected to yield numerous additional unexpected discoveries. The James Webb Space Telescope has revolutionized our understanding of the universe with its unparalleled observations of galaxies, stars, and planets. As the replacement for the Hubble Space Telescope, JWST has provided the scientific community with a remarkable instrument for exploration. People around the world are sharing its images and evaluating raw data to generate new insights. Since its first historic image was revealed last year, JWST has continued to astonish astronomers with its precise observations. One of the most recent images is a hauntingly beautiful view of the cosmos, leaving scientists with more questions than answers. Just 1 month after its initial images were released, JWST revealed new details about galaxy mergers and star formation in the early universe. These pictures offer a stunningly clear view of the universe. Since then, more discoveries have been made, providing an enormous store of information. Documented observations include cosmic space that broke records, phenomena such as smoke from the Tarantula Nebula, stars on the verge of collapse into explosions like supernovae, and other extraordinary celestial objects. The telescope's cutting-edge technology allows us to peer deeper into space than ever before, unveiling previously hidden details about the cosmos. To celebrate NASA's release in its first year of operation, an image of a small region where stars are formed was captured. This is a RAW of the Oumuamua cloud complex. The picture shows jets erupting from newborn stars amidst vibrant purple cosmic dust, atomic hydrogen in the dust specks, and shadows on several stars hinting at the presence of circumstellar disks, potential indicators of planetary formation. This observation brings into focus the stunning process of star and planet formation, offering a glimpse into the birth of new solar systems. The Webb telescope's sensitivity to infrared light allows it to capture images of these dusty, distant regions where traditional telescopes would struggle. These images reveal the intricacies of cosmic dust and gas, often hidden from view, shedding new light on the conditions that lead to the formation of stars, planets, and perhaps even life itself. The telescope's work in this domain is not just groundbreaking in terms of its technical ability, but also in the way it challenges existing theories about the universe. For instance, the discovery of massive planets orbiting low-mass stars, as mentioned earlier, forces scientists to reconsider their models of planetary and stellar evolution. The James Webb Space Telescope, with its advanced instruments and state-of-the-art technology, is pushing the boundaries of our understanding of cosmic history and providing unprecedented insight into phenomena that were previously beyond our reach. As researchers continue to analyze the data from JWST, the telescope is poised to answer some of the most profound questions about the origins of the universe, the potential for life beyond Earth, and the nature of the stars and galaxies that populate our cosmos. Its findings could lead to a paradigm shift in astrophysics, altering the course of scientific exploration for decades to come. One of the most intriguing aspects of JWST's mission is its ability to look back in time. By observing distant galaxies and stars as they appeared billions of years ago, the telescope allows scientists to study the early universe in a way that was never before possible. This time machine function could provide answers to questions about the Big Bang, the formation of the first galaxies, and the evolution of cosmic structures. As the telescope continues its mission, the scientific community eagerly awaits the next set of discoveries. The James Webb Space Telescope represents a new era in space exploration, one where the boundaries of knowledge are continually expanding. Its observations have already changed the way we view the universe, and the potential for future discoveries is limitless. The journey to understand the cosmos is far from over, and JWST is at the forefront of that quest. With each new image and piece of data, we take one step closer to unlocking the secrets of the universe and understanding our place within it.